Hi thinkers, welcome to the Algorithms in Python playlist on thinkexacademy.com. In this video we are going to study the heap sort in Python, and we are going to write this program and try to understand each and everything in this program line by line. And since heap sort is strictly based on the heap data structure, we will first start with understanding what exactly is heap data structure, and we are going to write the Python program to implement the heap sort. So let's start with the first step, which is understanding the heap data structure. So basically a heap data structure is a binary tree representation of a given array. So let's assume that we are given this array which has these items, which is 2, 15, 4, 30 and so on, and we are also given the index positions of these array. Now what I want to do is I want to actually represent it in the form of a binary tree. So if we want to form a binary tree, we will call it as a binary heap. So I'm just going to write here binary heap, because this heap or this binary tree that we're going to draw here is actually a representation of this given array. So the first thing is how to construct this binary heap. We actually have three rules or three conditions which we will use to represent this array in the form of a binary tree. The first rule says that the root of the binary tree will be equal to the array and the position of this root will be equal to 0. We have a second rule which says that the left child or the position of the left child is going to be the array. We will multiply 2 multiplied by I, where I is the ith node where I wish to find out the left child, and then I'm just going to increment it by 1, and this is how we can get the left child. So the binary tree is we are going to build it by using these conditions. So whenever we want to assign an element to the left child, we are just going to take out the position by using 2 multiplied by I plus 1. And similarly for right also we have a very similar construction, which is we are going to use the array 2 multiplied by I is the ith node. Instead of 1 we will write 2 here. If we want to calculate the parent node of any child, we can do so by just using array, and the position of this node will be equal to I minus 1 divided by 2. Alright, so now let's use these three rules to construct this binary heap. The root of this binary heap is going to be 2, because that is the position of the array. So here I am also going to write that this is the root, and I will write the position in square brackets here. So this is actually 0. Now let's see how to get the left and the child nodes of this binary heap. To get the left child, we have this formula, which is 2 multiplied by I is the position of the ith node. You can see the position of I is 0 in this case, right? So I is the parent. So this is 0. So 0 multiplied by 2 will give me 0, and the final position we will get is 1, and at one position we have the element 15. So here I am just simply going to write 15 and the position is going to be 1. Similarly I will use this formula again, and now we will have the value 2 here. So at the position 2 we have the value 4 here. Now we have understood a very simple pattern here. Instead of recalculating the values using this formula, we can use this 0, 1, 2 and then 3 will come here, then 4 will come here, and then we have 5 and 6. So 5 will come here and then 6 will come here. Alright, so let's see what are the elements at these specific positions. So we have 30 here, and at 4th position we have 18, at 5th we have 6, and then finally we have 25. So this is the binary heap that we have constructed from this array. This heap is particularly not useful. So in order to make it useful, we have two different types of heap that we can build. The first of them is a max heap, and the second one is the min heap. Now the max and min heap are very useful when we are trying to implement a heap as a priority queue. So here you can see I have written it in the brackets here, which is a priority queue. A priority queue is a queue where the first element of the queue will have the highest priority or the minimum priority or the maximum priority. It is based on what we choose out of these two options. So what is a max heap? The property of a max heap says that the value of the parent node inside of the binary heap will always be greater than the values of the child nodes, right? So whether it is the left child or the right child, the value of the parent will always be higher. In case of min, we have the opposite condition, which is lesser than. Now let's see how we can build this max heap, and we are going to in this tutorial we will just use max heap. We can just invert these conditions, these operators, and we will obtain a min heap. So let's see how we will write the algorithm in Python also to basically understand how to implement this max heap. So what I just want to do is I want to convert this binary heap into a max heap, which has this specific property, right? So the first thing is I need to find out, we will create a function which is a heapify function, and let's call it as a max heapify function because this is a max heap. Alright, so now we have to decide how to max heapify, from where we should start the max heapify function, and then we will use recursion to do it for the rest of the elements of this binary heap, right? So the general rule is that the max heapify function will start from this node here, right? So if we have any type of tree, we are going to start from this node. Now how we can reach this node is the main reason why we are not starting from the leaf nodes. You can see that these are the leaf nodes, and the leaf node, at the leaf nodes we do not want to call the heapify functions. So in order to avoid that, we will have to start the max heap from the one child above the leaf nodes, right? In order to reach this position, we have a very simple formula, which is n floor division 2 minus 1. Alright, so here n specifies the size of the given array. So what is the size of the given array? Here you can see we have 7 elements as here. So n is going to be 7. N divided by 2, which is 7 divided by 2 is actually 3.5, but since we are using n floor division 2, what it will do is, because we are not interested in these decimals, it is going to remove these decimals and it will give me the value 3. Alright, so here you can see we have the value 3 here as this value. Now what I will do is I will subtract it with 1, so now I will get 2 here. So now we are going to call this max heapify function at this position 2, right? So this is what we have got from our given array, and it will hold true for all the given arrays. This is a general formula which is actually used to ignore the leaf nodes and to start from this position. So now you can see we can start from this, or we can even start from this position as well. So we will start from this position because after that we can actually move here, which is 1. So we will start with this position, which is 2. So now max heapify will come at this place. Now what we want to do is we will, whenever it will call it, we will call this max heapify function on this position 2 according to this formula. Now I'm going to assign this node as the largest element. Now this is obviously not the largest element. I am just going to assign it as the largest, and in the future I will reassign it to the element which I found greater than this element. So the way to do is I will first check it with the left node. Here you can see the value of left node 6 is greater than 4. So now the largest will get assigned here. So I'm just going to show that this is now going to be the largest element after we will check a condition. Now what we will do is we will check the right part. In the right part we have 25. Now we will not compare with 4 here because now the largest is reassigned to this value. So we are going to compare 25 with this value, which is 26. Now 25 is greater than 26, so now the largest value is going to point here. So that's how we keep reassigning these elements to find the largest element. Now largest is pointing to the largest element. What we will simply do is we will simply swap it with the parent value, which is 4 in our case. So here I am going to show a swap symbol here. So we are actually trying to swap these values. So after I call the max heapify function, I will just reassign the largest value. That's the second step. So I'm going to write here reassign largest. And the third step is very simple, which is to swap the values after we have found out the largest element, right? So we will write a swap function which will basically swap these values. So after this, after the first iteration, the max heapify 2 will build a max heap for this subtree, right? So we will obtain a max heap here. Now what we need to do is we will have to perform this max heapify function on all these nodes, which is 1 and 0. So we are going to call this function max heapify on 2, and then we are going to actually write a for loop, which basically what it will do is it will start from I equals to n divided by floor division 2 minus 1, and it will go till the value of this I is equals to minus 1, and at each position I am just going to make sure that the value of I is decremented by 1. So now max heapify will start from 2 because we have calculated here it was 2. In the next iteration, the value of I will be decremented by 1. So max heapify will be called at this position, which is here. So I'm just going to write that this is where the max heapify function will call, which will finally build a max heap at this subtree. And then finally we will again decrement the value of I, and the max heapify function is now going to point here, and it will finally build a max heap. One important property of a max heap and a min heap is that in case of max heap, at root you will get the maximum element, which you can see obviously in this case also, because we are writing the conditions and we are swapping the values. So at root we obviously got the largest element out of all the children, and in case of min heap we are going to obtain the minimum element. So this is the theoretical part of binary heaps, max heap and min heap, and we have discussed this algorithm now. So let's try to implement the heap data structure now. In the previous tutorial we have briefly studied about the algorithm, so let's try to implement it here. So here I'm just going to write a comment that this is a heap implementation. Alright, so the first thing that we need to do here is we will have to first write the driver code. The driver code is basically the code that is going to execute all the functions here. So the first thing we need to do is we are going to create an array, and let's name this array simply as ARR, and let's insert the elements that we have chosen from the previous tutorial, or let's just assign anything here. So I'm going to write 2, 66, 30, 5, 9 and 10. So these are the elements of the array, and now what I will do is I will create a variable n. This variable n is basically going to get the size of the array, which we can use the function length, and here I'm just going to write the name of the array, which is here. Alright, so now we have the size of the array. Now the next task is to build a max heap. So here I am going to write here build a max heap. One important thing is that this whole code will be available on our website thinkxacademy.com, so do check it out after the end of this tutorial. Alright, so now we know that we will have to create a for loop, and this for loop will run from I, and it will go till the range, which we are going to specify that initially the value will be n floor division 2. We have seen that minus 1. This is where the range will start. So the I will have this value n floor division 2 minus 1. The second argument here, which I am going to write here, is going to be minus 1, and this argument basically says that we will stop when the value of I will be equal to minus 1. And the last element is the minus 1 also. The last parameters of this range function specifies that it is actually the value of I is going to be decremented by 1, right? So this argument here is going to decrement the value of I by 1, and this here is going to check whether the value of I is greater than minus 1 or not, right? So here we have the for loop. And now what I am going to do is I am going to make a call to the heapify function. And to the heapify function, first we need to actually give some indentation here, and then I will call the heapify function. And let's make this function as a max heapify instead of a heapify. to this function I am going to provide the array as the argument, the size of the the size of the array, and then I will be the position from which we wish to start the max heapify. And finally, in this driver code only, I am going to display the elements of the array. So let's quickly do that. So here I will just write print array, or let's say the max heap is, and here I will just create a for loop that will go from I in range n, and every time I'm just going to print the value of array 1 position here, right, array I, and what I'm just going to do here is it will be separated by a comma also, right. So this says array is not defined because A should be capital here, right. And now here we have the max heapify function. It says that this is not defined, so let's define it here, right. So here we have the max heapify function. Now let's create this max heapify function. So I will just type max heapify, right, and let's define it. So the way to do is use define max heapify, and here I'm just going to simply write all the 3 parameters that we were passing to this function, which was the array. So it was ARR and the size of the array and the position. Now simple task, what I'm going to do here is I'm going to create a variable which is the largest variable, and this variable will be equal to the ith position, right. So here we have this largest value here, which basically is actually pointing to the root element. Now what I'm going to do here is I'm going to create 2 more values, which is left and right. So left equals to, we know the rule to calculate the left position is 2 multiplied by I plus 1, right. We have already studied it in the previous tutorial, and obviously we will have to remove these semicolons because we are actually programming in Python, not in C++. So here we have the right position, which will be equal to 2 multiplied by I plus 2, right. So we have created 2 positions, left and right. We have assigned the largest element. Now what I'm going to do here is I'm going to create a if case, and in this if case I'm actually going to check whether the largest value so far, so largest so far, is compared with left child, right. So here we are going to do that. So in here what I am going to do here is, first of all, let's leave some space here, and here we have the define if case. The way to do is we are first going to write left should be less than the size of the array. That's the first condition, and the second condition is that the value at the largest position should be less than the value at the ith position, sorry, the left position, right. So we are actually comparing it with the left child. So what we are just doing is we are actually trying to compare it with the left child here with the largest element. If we find out that this largest value is actually less than the left value, since we are building a max heap, we will have to reassign the value of left, sorry, the largest value, because we are concerned with the largest value and it is going to point at left. Alright, so now what I'm going to do here is I'm going to write the second condition, which is also very simple. We're going to say that the largest so far, so let's say now the largest is assigning to the left. After that we are going to compare it with the right, so it is compared with the right node or the right child here. So the way to do is also very simple. If the right is less than n. That's the first condition that we need to check, and we also need to check the value of array at the largest position is less than the value at the right position, right? So we are just checking, we are just finding out and assigning the largest value in the whole subtree, right? So here we are reassigning the largest to right. So what we have done is we have just find out the largest element, and now what we need to do is we want to swap it with the value at the ith position, right? So now we are going to first write a condition, right, which is here we will have to change the parent, and the way to do so is, first of all, I will just check that the largest value is not equal to the ith position, right? Because in that case we do not need to swap. If the value of largest is already pointing to the parent, we do not need to change the parent or swap it with the largest value. Now we are going to write the command, write the line which will actually swap it. The way to do is very simple in Python: array ith position, then the array largest position, right, is going to be equal to the array largest position, comma, array ith position, right? So this simple line is going to just make sure that we will swap the values of the array at the position ith, which is the parent or the root, with the largest element which we have actually calculated from these two conditions. So now this function is complete, but we need one more step, which is to make a recursive call to this maxheap5 function, because we need to call this function on the root nodes or the child nodes as well, right? So here I'm going to write recursive call. In this recursive call, I'm just going to call the maxheap5 function, and I will give it the array, the value n, and the largest value. So now what it will do is it will again maxheapify, but here instead of ith position it will start maxheapifying at the largest position. So here what we are just trying to do is make sure that the heapify function is being called on each and every child node also. So this is going to make the recursive call, and this will actually make the whole subtree as a max heap, right? So we need to make sure of this important recursive call here. So now the code is final. Let's try to run it. First I am going to just save it, and now let's run this. Here I'm going to just write the command python3, name of the file is heaps.py. Alright, so you can see here maximum recursion depth exceeded in comparison. So what I'm going to do here is I'm just going to exit it from here. So let's see what is the actual error that we are getting here. Alright, so I can see the problem here. The problem is in this line, which is this recursive call. The reason why this is happening is this maxheapify function should be called only when we are changing the parent. So it should actually be indented inside of this if condition. So in Python it is very difficult to actually do the indentation part. You are going to actually see a lot of errors because of this. So this is how it should be written. It should be inside of this case. So we are going to actually call the maxheapify on the largest part only when the largest is not equal to the node that where we want to perform the maxheapify. So let's change this again. So let's try to run this program again. Alright, so you can see here this is the max heap. You can see the first element which is at the 0th position is 66, and you can see it is the largest of all the values of our array. So indeed it is a max heap. Our program is working. And now you can see the first element on the left side, it will be 9, and on the right side we have 30. And we are going to just do this again. We can convert this heap to the array again, and you will observe that it is a max heap, right? Then what we can do is we can use this max heapify function to also perform the heap sort. Okay, so now let's move on to the heap sort part. So here we have obtained this max heap by implementing this whole program. And here you can see I have created this max heap in the form of an array here, and I've built it in the form of a binary tree. And here you can observe that at the root of this heap, the element that we have obtained is actually the largest number of this whole given array. So after every max heapify function call, we will obtain maximum element at the root position of the array. We can use this logic to our advantage to perform the sorting. So what you can do, what we can actually do here is that 66 is actually at its right position. So you can see that we can call the max heapify function on the remaining subset of these elements because these are not sorted. So if I will run max heapify from these elements, which is 9, 30, 5, 2 and 10. So what will happen is the maximum element will come at the first position of this array. So you can see that 30 is the maximum element, so it will come at the starting position of the array. Now we can keep doing this again and again to get a sorted array. Now the problem with this strategy is that since 66 is at the root position, if we disturb the root position, it is going to disturb the whole algorithm. So one intuitive strategy to actually prevent this is to actually perform the swapping of the integers. So what we do is we pick the largest element which we can obtain at the 0th position, and then we can actually swap it with the last element of the array, which you can see is 10 here. So I will first do a swapping of these elements. So now after swapping these elements, you can see we will obtain 10, 9, 30, 5, 2 and 66. Now what we can just do is we can actually perform the heapify function from the 0th position to the n-1th position. So we are actually disregarding, or we are actually removing this node from our observation in the max heapify function. So now this is the observable array which we will pass to the max heapify function, and we will keep doing this. We will keep decrementing the value of n which we are passing in the max heapify function by 1. So every time we decrease, we are actually disregarding the last position. So we are doing this because this is actually at the sorted one. So this is actually at the right position. Now here if we perform the max heapify function on this given array, what will happen is 30 is here. So 30 will come at the 0th position and we will get the rest of the heap. We will again perform the swapping, which is we will swap 30 with the last element. So 30 will come at this position and we will keep doing this again and again. Right, now let's move on to the part where we need to actually implement this this heap sort function. So the first thing is I'm going to make a call to the heap sort function and I will provide it with the array. Right, so here I'm going to create the heap sort function, the definition of the heap sort function. To this function I will have to actually just give the array like this, and this is our heap sort function. And here I am going to do the very first step, which is perform I will write a for loop which goes from I in range. Now the range of this function, since we want to perform the heap sort from 0 to n-1th position, so this will start with the n-1th position and it will go till 0. So we are actually going to move in the backward direction, which is n minus 1 to 0, and we are going to take a step count of -1. So the value of I keeps decrementing by 1, and it starts with the n minus 1th position. So n is actually 6 here, which is the length of this array, and n minus 1 is 5. So initially we are actually creating a for loop which goes from 5, then 4, then 3, 2, 1, 0. So the value of I will be 5, 4, 3, 2, 1 and 0. So we need to actually now do the first part, which is to do the swapping. So I'm going to write here a very important comment, which is to swap. So I will have the array which is here, and we have the ith position, which is the last position, right? So first the value of I will be equal to 5, as I goes from n minus 1, which is 5 till 0, and here it will be 0, right, because I want to swap it with the root element which is at the 0th position, and I will simply write it like this, right? So this is one of the ways to actually perform the swapping. Here it will be ith position. So now we are done with swapping. We keep swapping the value of the root element, which is 0, after each and every max heapify call. At the root element we get the maximum element, so we are going to swap it to the last position, which is the ith position. Okay, so now let's do the main thing, which is calling the max heapify function. This function takes actually 3 arguments which we have implemented. One is the array itself, so I will give it the array, and then it needs the n number of elements. So n will we will not write n here, we will write I here, because we want I, which is the number of elements, to decrement after every iteration. So I was initially 5, so the value of n was 5, then it will be 4, then 3, then 2, then 1 and then 0. And here we need to provide the ith position, which is actually the largest element. So I will provide 0 here, which is actually the largest element of this array. Now this will go again and again, and it will sort this array. So now let's change it to max heap to sorted, and here I'm just going to write that this is sorted array. I'll save this and let's try to run this again. So now you can see that I now have the sorted array, which is 2, 5, 9, 10, 30, 66. That's all for this tutorial. Thanks for watching.